Yesterday we were talking about updates, the cluster updates. Okay, so I've shown you practically how this updates works. Okay, so I'm sharing my screen. Okay, so this is the upgraded cluster what we have now. Let me see. Yeah. Today is 27th, right? Okay. Okay, so yesterday we were talking about upgrades. So yesterday we extended our time and finally we were successfully able to upgrade our cluster. Okay, so this is the upgraded cluster. And let me log in here. Upgraded cluster, and okay, so if you see the if you want to see the latest version, click on Manage Ambari and click on versions. So now you can see what is the current version. Okay, so earlier it was 3.1.0 and now it is 3.1.4. This is the current version. Okay, understand? Okay, so like that. Okay, so suppose okay tomorrow if you have 3.1.5, okay, just click on register version. Okay, and pass the 3.1.5 repo files and repo path and all, and okay, just okay, click on install. So once okay, it is installed, then okay, you can click on upgrade. Okay, so this is how okay, you'll be doing the upgrades. Okay, so cluster upgrades. So at the high level, okay, so these are the steps. Okay, if somebody asks okay in the interview, okay, so you can tell okay how the cluster upgrades will happen. If it is a Cloudera upgrade, okay, so these are the steps okay we perform. Okay, I've given the document for Cloudera also. So I will be showing okay, only one upgrade. Okay, so other upgrade, the Cloudera upgrade you can perform. Okay, so Hortonworks upgrade. Okay, so these are the high level steps okay which we have done yesterday. Understand? Okay, so if you have any questions on the upgrade part, okay, please let me know so I can explain. So normally, okay, so people may ask in the interview like, okay, what is the upgrade process and okay, what are the issues okay you faced okay, during upgrade process? Okay, so that's one of the common question okay you may see. But okay, when it comes to issues, okay, normally, okay, we should understand the process of upgrades, guys. Okay, so when you take any company, so you definitely you will have okay one sandbox, okay, sandbox cluster, okay. Sandbox are okay cluster. This is the first one. Okay, so then okay you will have dev cluster, you have okay UAT cluster, and you have production cluster. Okay, and okay you may have DR cluster also, right? In some places. Okay, or okay, some places okay we use UAT as a DR. Okay, so UAT or DR. Okay, disaster recovery DR. Okay. So now this is a sandbox or test cluster. Normally this is okay like a 3-node cluster like this. Okay, this cluster size will be maximum of 3 to 6 nodes. 3 to 6 nodes. Understood? The size of the cluster will be always 3 to 6 nodes. Okay, not beyond that. Okay. So what they will do? So the dev cluster, UAT cluster, and the production cluster is purely depends on the size of the data we have. Okay, so if you ask, okay, what is our cluster size? Okay, so we have around 130 node dev cluster, 130 nodes altogether. Okay, so when it comes to UAT, around okay, we have 1100 nodes. Okay, and production okay, nearly we have 2000 nodes. Okay, so this is the situation. Yes. Okay, so. Okay, so normally any company sandbox or test cluster will be like 3 to 6 nodes only. Okay, so whenever they are upgrading a cluster, Okay, so which cluster they upgrade first? Will they directly upgrade production cluster? Definitely no. Okay, so if you start upgrading production cluster and something went wrong, so your entire production will be impacted. Okay, so that's the reason. Okay, they start with sandbox cluster. Okay, even sandbox cluster is gone also. Okay, no problem. They will recreate this cluster with a script, simple script. Understand? Okay, so no problem at all for this cluster, even if it is lost also. And this cluster will be only it's only used by Hadoop admins. Okay, this cluster. Okay, so this cluster will be used by people like our developers. Okay, or your clients. Okay, admins or users. Anything. Okay. So, but this cluster is only used by Hadoop admins. Okay, nobody else will be able to log into this sandbox cluster. Okay. So what they do? So first, they start upgrading this cluster. Okay. So they start upgrading this cluster. Okay. If you see all these 4 clusters, only the difference is that the properties, configuration files, everything is same except number of nodes. Understand? Except number of nodes. Okay. The rest of the property files are same here. Okay, for all the clusters. Okay. So here, first they upgrade the sandbox cluster. Okay. So and they will prepare a document actually. Okay. So they will do the testing on upgrade testing on sandbox cluster, and they prepare all the steps. What are the steps? Okay. So while perform this upgrade, even it failed, also not a problem. Okay. They will recreate the sandbox cluster once again, and again they'll start the upgrade part. So I've seen many times the sandbox cluster is going down. Okay, again we are creating a new sandbox cluster and starting our upgrades. Okay, so they'll upgrade this one. They'll prepare a document, upgrade document. Okay? So prepare upgrade document here. Okay, so once this done, okay, so then what they will do? They will start upgrading the dev cluster first. Okay? Let's say they upgraded the dev cluster today. Okay, so what they will do? So they will complete so dev cluster means they can go with the express upgrade or rolling upgrade. That's up to them. Okay, they upgrade the cluster on okay, let's say today. Okay, so once it is cluster is upgraded, what they will do? They will give time. Okay, they will give time till 3 weeks. So till 5/18, it means 3 weeks they will give time. Okay, so during this time, during these 3 weeks, okay, otherwise I'll put it here. Okay, this is equal to this plus 21. Okay, so during this time, during this 21 days, what developers will do? Developers will start using the new version of Hadoop cluster. Okay, that means upgraded version of Hortonworks or SDP. Okay, so if they come across with any issues, okay, okay, so they'll get back to us admins. Okay, or in other scenarios, okay, what they do? Okay, suppose if they feel that there are some places where some improvements can be done. Okay, so they will suggest us. So finally, okay, so on 5/18, okay, we will decide whether this version is stable or not, and this version can be installed in UAT also. Okay, so what we do? Okay, if all okay, then what we do? So normally, very next day, after 21st day, okay, we upgrade the UAT cluster. Okay, after upgrading this UAT cluster, okay, we give again 15 days time here. Okay, so here okay, they do the performance testing and all. Okay, so once it's also fine, and only so they'll start upgrading this cluster, production cluster. Okay, even production cluster also, after upgrading this production cluster, they will keep it open for 7 days. Okay, it means they will not finalize the upgrade up to 7 days. Okay, if finalize upgrade option is not used, then you can downgrade the cluster any point of time. Okay, once it is finalized, okay, you cannot downgrade. Okay, so mostly this process is very important. How many days you keep? Okay, let's say if you are attending some manager rounds, okay, they'll ask this kind of timelines actually. How many days you keep? Okay, open. Okay, open upgrade for development cluster. Okay, and how many days for UAT cluster? How many days for production cluster? Okay, so this is how. Okay, so they do the upgrade process. Okay, so every step. Okay, so here okay, they may take okay, so 100 steps here. Okay, so maybe here when it comes to dev, okay, so they will add okay 10 more steps. Okay, 10 steps. Every environment, whenever the environment is growing, So they will be taking up more and more care. Understood? Are any questions? Okay, so this is the process of your upgrades actually. Okay. The next, if no questions, I'll go to the next module, backup and disaster recovery in Hadoop. Okay, so how this backup and disaster recovery works in Hadoop. Okay, so what even of backup and disaster recovery, guys? What even of backup and disaster recovery?
Lose the data in
suppose let us take the scenario. So this is my Hadoop cluster. This is my Hadoop cluster in Mumbai. So here, okay, I stored all my Reliance Fresh data. Okay, Reliance Fresh data. Okay, here I stored all my Reliance Fresh data. Okay. So now the question is that suddenly there are some floods in Mumbai. Okay, and there is some fire accident here. Suddenly, entire cluster is down. Okay, entire cluster is down. Or okay, let's say okay. So you have 5,000 stores. Okay, let's say 10 stores data got deleted. It may be partial deletion or okay, full deletion. Okay, so somehow okay, this cluster got damaged. Okay, see, we cannot give any guarantee to anything, right, in the world. Okay, so somehow this cluster got damaged and you lost all your data. Okay, let's say you are storing okay last 10 years data in this cluster, all 10 years data gone. What to do? What to do? So this is a completely data loss only, right? So that is the reason okay, what normally companies will do. So they create a similar cluster in a different location. Maybe okay, so I'm giving Delhi, or maybe I'm giving Chennai. Okay. So the other Friday, okay, so creating a different cluster. So every 1 hour, what they do, okay, so they will start pushing the data from this cluster to this cluster. Whatever the new data comes into this production cluster, so they push it to DR cluster. So that okay, tomorrow due to some reason, okay, if entire cluster is gone also, okay, you can still have your data available in this Chennai cluster. Okay, so this is nothing but your disaster recovery. So are backing up your entire data to different clusters. Okay, so and again guys, okay, so here this backing up, okay, is it like okay they do the full backup or okay, so let's say okay on this cluster okay, we have multiple projects. Okay, or let's say this is a banking cluster. I'll give you one more example. Okay, so this is a banking cluster. Okay, so HDFC Bank clusters. Okay, here also you have HDFC Bank cluster. Okay, so this is in Mumbai, this is in Chennai. Okay, so when I say HDFC bank cluster means okay, you will have multiple projects running on this one. Okay, so you will have accounts project, you will have loans project, credit card project, you will have okay, loans project, and okay, you will have insurance project. These are the different projects okay, what you will have running on here. And again, okay, it is up to you to decide okay whether you want backup for accounts data or not. Okay, or whether you want data for a credit card data or not. Okay, or inside account I may be having okay, so okay, find a TV data. Okay, but in that find a TV data, 100 TV data is very important. 200 TV is not so important. Okay, it means okay, even if we lost also, that's not a critical data. Okay, so in such scenarios, okay, so you can keep okay, so 300 TV. Okay, so here okay, you can decide okay, like you means okay, not admin space. Okay, so developers will tell, our project manager will tell, accounts manager will tell. Okay, so I have total 500 TV data. So critical data is okay 300 TV. Okay, which requires backup. Okay, so non-critical is 200 TV. Okay, so okay, so in this scenario, so whatever critical data they have, so they will give the path, okay, the critical data path. Okay, so we need to schedule a backup. We need to set up a backup schedule so that okay, every 1 hour or okay, every day. Okay, so based on your requirement, okay, your data will be pushed from this from production cluster to DR cluster. Understand? Okay, maybe credit card team is saying that okay, so I have okay 200 TV data. Okay, but only okay, but all 200 TV is important. Okay. So if alt 100 TB is important, then okay, so then critical data is 0 TB. Okay. Loan section, okay, they say that okay, so I have 100 TB data, but okay, so okay, this is not critical data. Okay, so then okay, I may ignore. I may not push okay loans data to, because okay, they don't want okay whatever data they have is a non-critical data. Okay, they don't want anything in the DR cluster. Okay, so based on the requirement. Okay, so here based on the requirement, okay, so critical data, non-critical data, 0 TB. So in this scenario, account section, okay, so we do the partial backup, okay, and credit card section full backup, okay, loan section no backup, and insurance section also full backup. Okay. So it is purely depends on the manager, this project manager decision, not by admins or anybody, because okay, we don't know what data is critical for them and what data is not critical for them. Understood? Okay. So what to do? Okay, so this is okay. So at the high level, this is backup and disaster recovery. Okay, this is backup and disaster recovery. Okay, so now the question. Okay. So we are talking about backup, right? Okay, so what are the possible reasons for okay data loss? So why you go for backup? Okay, because okay, there is a chance of data loss. That is the reason you go for backup. Okay, so what are the possible reasons for data loss? Okay, so possible reasons for data loss. Okay, so we will see that. Okay, so let us take, okay, this is my cluster. So this is my cluster, this is my name node. Okay, these are my 3 data nodes. Okay, in each data node, okay, I have MNT disk 1, MNT disk 2, MNT disk 3. Okay, so now in each disk, okay, I have some blocks. Okay, so here, okay, so if you see block 4, okay, so block 4, 1 copy is here. Block 4, okay, 1 copy is here. Okay, so block 4, 1 copy. The replication factor equal to 3. Okay, so block 4 is here. Okay, so now, okay, the first possible reason is okay, what in case if a block in the cluster, okay, not whole cluster, okay, got damaged. Okay, the first one is okay, what in case if block is corrupted? Is there any chance that a single block is corrupted? Huh?
Yes.
Single block is corrupted. Huh?
Yes.
So what I will do? Okay, so I will add a few more. Okay. Okay. So and again, okay, so this is rack 1, rack 2. Okay, so this is rack 1, rack 2, and rack 3. Okay, so this is rack 1, rack 2, rack 3. Okay, so normally what will happen when there is a cluster? Okay, let's say this is name node 1, this is name node 2. Okay, so this is my cluster, 2 name nodes. So and I have multiple racks here. Okay. I think that, okay, so let's say you're copying a file. Okay, so BLK1. Okay, so one copy here, BLK1. Okay, BLK01. Okay, the same BLK01. Okay, you will have, okay, BLK01, and okay, you'll have BLK01. Okay, so BLK01. Okay, so like this. Okay, so you have BLK02. Okay, the same BLK02. So maybe here one copy, maybe here one copy. Okay, so BLK03. 03. Okay, BLK03. Okay, so BLK03. Okay, BLK04. 4. Okay, so BLK04.
This is single cluster, yes. Ankit, like
Okay.
3 copies.
Yeah, this is a single cluster, sir. This is a single cluster. Okay. So now, okay, the thing is that, okay, what in case, okay, let's say there is a block. Block 3 is corrupted here. Understand, guys? Okay. So there's a problem with the block 3. Okay. So what will happen? What will happen to my data? Is there any impact, okay, if block 3 is corrupted due to some issue? Okay. So failure scenarios. Okay. Data corruption on disk, the first one. Okay. So the block 3 is corrupted. Okay. Is there any problem if block 3 is corrupted? The same block 3 is available, one more copy. Okay. So here one copy is available, and okay, somewhere, okay, here also one copy is available. Okay. So not here. Should not be here, right? Okay. So same block 3, any block is corrupted, okay, the same block 3 is available here also and here also. Okay. So if block 3 is corrupted, what NameNode will do? NameNode will automatically identify if there is a corruption in the block. Okay, and okay, it will try to replicate this. It will ask this data node 1 to delete this block, and okay, it will tell that data node 2 to copy the block from here to here. Okay, it means, okay, if any block is corrupted, okay, so deletion of those corruption block and okay, replacing that corruption block with the correct block, okay, is the responsibility of NameNode. Okay, so if a block is corrupted in the cluster, okay, if that block is having replication, so no need to worry about that block. Okay, so block corruption will be handled by NameNode. Clear?
That black corruption, how do it know, sir? Is it corrupted or not?
So how it will be knowing if this is corrupted or not? So
Yes.
you know, here we have data node, right? Okay, so what data node will be doing every day? Okay, so whatever the blocks which are more than 21 days old, okay, so it will be checking all the blocks it has. Okay, so how it will validate this is a correct block or corrupted block? Okay, so there is a file. So for every block, okay, you have something called .meta file. So what is this .meta file? So .meta file will contain the checksum value of that particular piece of data. Okay, so if block 3 is corrupted, okay, the checksum value, okay, will not match, okay, with the checksum value which is there in .meta file. Okay, see, every block will have your block plus block.meta. Understand?
Yes.
Okay, so block.meta will contain the checksum value. Okay, so what data node will be doing every day? Every day it will take each block and block.meta. So it will calculate the live checksum value of this one, and okay, it will compare that with the .meta file. If both are matching, then it is a valid block. Otherwise, it is a corrupted block.
Corrupted.
So like that, okay, data node will only will identify this is a corrupted block.
So every day or once in 21
Every day,
days?
sir. Every day. Okay, and okay, so whenever it finds that there is any discrepancy in the blocks, okay, data node will inform NameNode immediately. Got it? Okay.
Yes, sir.
So what NameNode will do now? Okay, so NameNode will tell the data node, okay, hey, delete this block 3. So data node 1 will delete the block 3. Okay. Now NameNode 1 will tell the block, data node 2, hey, you copy block 3 into this machine. Data node 1. Okay. So this is how. Okay. This is how it works actually.
Sir, we have one more command like find plus loss command. No, sir.
So that is also, sir. Okay. So that is also will do the on the fly check action.
Your voice is not audible, sir.
Yeah. So there is a command list corrupt files, right? FSCK list corrupt files.
Yes, sir. That is manually done by us, right?
Yes. Okay. That's a manually done by us. Okay. So if you want to do this one, okay, you can do it manually.
Okay, sir. Thank you.
But sir, let's
Okay.
say in this case, if one block is corrupted, does user get any error, or will he get
No,
his
okay.
data
User
from
will not be knowing at all, okay, about this one. It's all internal process. Named will take care. Got it?
Okay. Thank you.
Okay. So this is okay, one way block corruption. Okay. So what in case, okay, in the next scenario, what in case, okay, if entire disk itself is corrupted?
It will send. It will not send the heartbeat like.
So if disk itself is failed, what will happen? Okay, whatever the blocks, okay, we have inside this hard disk, okay, everything will be lost. Yes or no? Okay.
Yes, sir.
If disk 2 is failed, whatever the blocks it has, okay, here, all those blocks will be failed. Okay. So now what data node will do? Data node will send information saying that, okay, say I don't have these blocks now. See, normally what data node will do, whenever there is any change in the number of blocks, okay, it will send a report, block report to individual block report to name node. You remember this concept, initial concept?
Yes, sir.
Okay. So
Yes.
here, okay, what is happening? Okay, suppose, okay, if any disk is down, now it will send a report saying that, okay, I don't have block 3 and block 5 now. Okay. So now, okay, this data node 1 will tell, okay, so please remove my name for block 3 and block 5 because, okay, I don't have those blocks now. Okay. So now, okay, name node will remove data node 1 name, okay, for block 3 and block 5. Okay. So when it is removed, then, okay, in the block report, these two will become under-replicated blocks. Correct? So when there are any under-replicated blocks, automatically name node will create one more copy of these blocks. Okay. So here, okay, block 3 is available here and here also, and block 5 is available here and here also. Okay, so no problem to my data. So even if entire disk is failed also, you will not get any alert. Okay, so disk failures also will be managed by, so disk failures can be handled by name node itself. Okay, so you no need to involve anywhere, okay, here. Okay, you don't need to involve anywhere here. Okay, this is about disk failure. Okay, the next one is, okay, let us talk about the entire rack failure. Okay, so this entire rack is failed. If entire rack is failed, what will happen? So it means, okay, whatever blocks available here, okay, those blocks will not be. So whatever data nodes available under this rack, okay, they will not be available. Correct? If rack is failed means, okay, whatever data nodes under that rack, okay, all those things will be inaccessible. Okay. So, but even though inaccessible, okay, so is there any problem for us? If you remember a block placement algorithm, what a name node will do, every time when it is writing a block, okay, it will write first copy in one rack and second copy in, okay, so if you see block 1, so block 1 is here, okay, here also, okay. So first copy will be in a first rack, okay, in a available rack, okay, and second copy will be in a data node in a different rack, okay. Second copy of block 1 is written in the rack 2 data node 4, okay. Third copy of BLK1 is written in the rack 2 data node 5. Understood? Okay. So since, okay, you have block placement algorithm, okay, there is no problem even if entire rack is failed also. Okay. So entire rack is failed also, you still have data blocks available in other racks. Replication blocks are available in other racks. Okay. See, for block 3, you have, okay, 2 copies here, 1 copy here. Even entire block which is gone also, still have 1 more copy here. With this copy, okay, it can create 2 more copies. Okay. And block 2, 1 copy here. Okay. So 1 copy here and here. Okay. Block 2. Okay. So no problem for block 2 also. Okay. So block 3, 1 copy here, 1 copy here. Block 3, no problem. Block 1 also no problem. Okay. So block okay, so block 5, 1 copy here, 1 copy here, 1 copy here. Okay, so for any block there is no problem because, okay, so not all 3 copies of the blocks will be in one rack. Understood? Okay, so what I'm trying to say here, okay, so here even rack failures also can be handled by, this will be handled by name node itself. Okay, so if entire rack is failed also, you will not get any alert at all. Okay, so that rack failure issue can be easily handled by name node itself, automatically handled by name node itself. Okay, as admin, you don't need to do anything from your side. Got it? Got it? Or any questions? Okay. So this is the data corruption. Okay, disk or node crash. Okay, rack failure. So enter disk crash also. So here. Okay.
So, sir, name node will automatically copy that whatever failures are there. It will and maintain 3 copies.
Yes, sir. So enter rack is down. Okay. If enter rack is down also, no problem. Okay. So okay, enter node is down. Okay. This is okay. So I explained about the block failure, disk failure, node failure, and last one is rack failure. Okay. So anything okay. So block failure corruption also will be handled by name node automatically. Okay. So disk failure can be handled by name node automatically. Node failure can be handled by name node automatically, and rack failure also can be handled by name node automatically. Okay. So there is no worry about your data if you replicate your data in Hadoop cluster. Okay. And okay, failures in Hadoop, okay, backend DB failures. Okay, so there are high chances that okay, your DB, okay, backend DBs. What in case if Ambari DB is failed? What in case okay if high Metastore DB is failed? What in case if your Sqoop Metastore DB is failed? They are important, right? They are metadata. Okay, so they are very important actually. Okay, so that is the reason. Okay, so for any Cloudera Manager backend DB or Ambari backend DB or Hadoop backend DB or Uzi backend DB. So you need to have MySQL backups or Postgre backups. Okay, so database backups are very, very important here. Okay, so normally, you know what we do actually. So here, okay, so you have development cluster, you have UAT cluster, and you have production cluster. Okay? So production cluster. Even okay, so we take backups for each database every day. Okay, then dev, okay, so daily once. Okay. And okay, we keep it for 14 days, last 14 days backup. Okay, it means okay. So at any point of time, if you ask me, okay, I will have last 14 backups. 14. Okay, so here okay for dev cluster. Okay, so whatever the DBs we have for all the DBs, okay, we take backup of all the DBs daily once, and okay, we store in a separate place. Okay, and like that, okay, we maintain last 14 days backup. Okay, so if by mistake, if database is corrupted also, we will restore with the previous day version. Okay, this is for dev. Okay, and when it comes to UAT, so we take daily 4 times. Every 6 hours, okay, we take the backup of DB backup. Okay, every 6 hours we take the DB backup, and again, okay, we keep last 14 days. It means okay, here okay, so 14 days means okay, daily once means 14 into 1. Okay, so 14 into. Okay. So 1.
That means it stores only 14 days of backup, right?
Okay, if I take a backup, okay, will it be like okay, only for today or okay, from day 1? Every day we have from day 1.
Yeah. Yes,
sir, RDBMS backup will not come so much, right?
Yes, sir.
Okay. If okay, we are using.
Sir, for a cluster to take backup for 14 days, it will be too tough. Yes, like kind of means to my understanding, cluster backup is nothing but same cluster is copied once. Yes. Or only data is only copied, sir. Like
sir, only data is copied. Yes. Sir, okay, this is metadata, sir. Okay, in RDBMS, what you will have?
Yes, sir. Metadata.
Metadata, how much it will come?
It will come. Metadata will come. Yes. But sir, what about data? Exactly the main data.
Okay.
Data is replicated, right? So you need not to take backup again. Maybe DR will be there where the same replication can happen.
Okay. Yes, can you see this one? What is Ambari database size as of today?
Yeah, 64 MB.
64. How many days we are using? So we have set up this Ambari almost 20 days back, or almost
Yes,
1
yes.
month back. Yes or no?
Yes, sir.
So from 1 month, if you see Ambari, so it stored only 2064 MB data inside it. Got my point?
Yes, sir.
And you take high metadata. We created around 20 tables. So but altogether it has come like 3.7 MB. It is in
Yes,
MB,
sir.
guys, not GBs. Okay.
Yeah, got
In
it, sir.
real
Got
time,
it.
even if you take Ambari database, if it comes like if it comes like 5 GB, that's too much actually. Understand?
Yes, sir. Got it.
Okay. So that's how they take the backup dates. So here, so and for UAT, the daily backups will be taken daily. I mean every day daily 4 times, and they keep for last 14 days backups. Okay. And when it comes to production, so daily, 24 times. Okay. So what does it daily 24 times? What does it mean? Hourly ones. Hourly ones. Okay. So it means So how many backups you will get? So 336 backups. Okay. Every 1 hour we take the backup of production cluster metadata DBs. Can we keep it for 14 days? Okay, that 14 days is our company strategy. Okay, so maybe your company may have different ones. Okay, but you can tell 7 days or 14 days minimum you can tell. Okay, if you ask me why 14 days, sir, even I don't have any idea why they are keeping it for 14 days. Okay. So this is the backend databases.
Sir, using any third-party tool, sir, for backup or?
Okay, see, if I want to take a MySQL backup, let me take this my Ambari backup, sir. Okay, so what I will do is an upgrade document. Okay, we have no third-party tool, nothing, sir. Okay, so this is the databases backup I'm taking. Okay, so I'm keeping in here. Okay, so this is okay. So now you see the size of this MySQL backup. How much it has come? How much it has come, sir? If I take a backup for all these databases, I've taken a backup now. How much it has come?
42 MB.
42 MB. 42 MB. This is the backup file, sir. Did I use any third-party tool?
No.
Every
So it is
database will
stored.
give you,
Where it is stored, sir?
stored in no, I'm storing in just now I'm storing in Ambari machine actually, but we may store in different place actually.
In real time.
In a shared drive, in real time we may store this in a shared drive. Got it?
Yes, sir.
Okay, yeah.
So for the RDBMS, we use the RDBMS specific backup, but for the HDFS, we solely rely on the replication.
Yes, at this moment,
Yeah, at this moment, okay.
Yeah. So RDBMS, we use RDBMS backup commands only. We don't use Hadoop backup commands to take backup of RDBMS. Okay. So metadata will be always so in Hadoop. The metadata will be maintained in RDBMS. Okay. So we use RDBMS backup commands to take the backup of RDBMS. Okay. For Hadoop, so far we have seen block failure, or disk failure, node failure, and rack failure. For all these failures, Nemnode will take care of the problems, or issues automatically. We don't need to worry about this one.
So we are also talking about replicating the data from the main cluster to the DR cluster, right?
I'm coming to that part also, sir. I'm coming to that part also. Okay. So the next one, so failures and scenarios, accidental malicious data deletion. Okay. So by mistake, there are 3 files on HDFS guys. Okay. There are 3 files. So you have sample 1.txt, sample 11.txt, okay, sample 111.txt. Okay. So your manager asks you to delete sample 11.txt. Okay. So you are talking in phone and by mistake you typed sample 111.txt. What will happen? If you delete a file, will all 3 copies be deleted or not?
Yes, sir. All three
Yes.
will be
Okay, all three copies will be deleted. Okay. So in that scenario, okay, so it is a data loss, right? But your manager asks you to delete, okay, sample 111. Okay, sample 11. Okay, but you typed one extra one, and okay, you deleted that file. Okay, now, so whatever file you don't want, it is there in HDFS. Whatever file you want, okay, that is not there in HDFS. Okay, you lost the required file. So how to manage this one? Okay, so to manage, okay, by accidental deletions. Okay, so we have some trash. So if you enable trash, what will happen? Whenever you delete any data, that will go and sit inside trash. Okay, so inside trash it will be there for 6 hours. Okay, so within 6 hours, if you find that there is some wrong file deleted, okay, you can retrieve it back actually. Okay, so here, okay, by mistake, okay, data deletion. Okay, so one option is that enable trash. So here, okay, so if you enable trash, okay, somebody deleted data, automatically it will come and sit inside the trash. Automatically it will come and sit inside the trash. Okay, and okay, come and sit inside the trash. Okay, and it will be there for 6 hours. Okay, 6 hours. Okay. If we observe that, okay, there is by mistake you deleted wrong data, then okay, within 6 hours, if you go and check the trash directory, it will be there. Okay, so what after 6 hours? Okay. Suppose, okay, you deleted a file, okay, evening 6 o'clock and left to home. Okay, so evening 6 o'clock you deleted means okay, it will be moved to trash. Okay, and okay, maybe by night 12 o'clock it will be permanently deleted. So in that scenario, there is no use of enabling trash also. Correct?
Sir, for that 6 hours can be extended to 12 hours.
Yes, sir. Okay, you can extend, sir. Okay, you can make it 12 hours or 24 hours. Okay, that's a pure configuration property. Okay, but okay, what is the point? Okay, if you delete a file, okay, and you are keeping it for 24 hours still on the hard on HDFS, so your file deletion is not creating any free space, right?
In our place, they totally disabled it, sir. They took this decision like a couple of years before because a lot of people deleting a lot of data and it's creating too much space.
Yes.
So if somebody deleted something, then they are then development team have to own it and they have to redo the data from this.
Yes. And again, okay, first of all, okay, admins will not touch any data, and admins will not delete any data. First of all, okay. So end of the day, data deletion, data copying also will be done by admin developers, and the data deletion also will be done by developers only. But only thing is that okay, if there is anything, okay, we need to set up the trash, enable the trash, okay, so that it will help developers. But okay, this is a problem here. This is the problem statement. Okay, even if I enable trash, okay, what in case if it is after 6 hours? It is a problem. Correct or not? Okay, it is a problem. Okay. Okay, and again, okay, so moving to trash, okay, moving to trash, okay, will work only with special. Okay, suppose, okay, you are deleting data from UI. I can upload data from name node UI also, right? I can delete data from name node UI also. Okay, but what in case if I delete data from name node UI, or if I delete data from Hue also have a file browser, or Ambari views. If I delete from there, then okay, that will not be moved to trash. Only if you use SDFS-DFS-RM command, then only your data will be moved to trash. Otherwise, okay, by any other scenarios, if you delete the data, that will not be moved to trash. Clear? Are any questions? Okay.
Sir, can you repeat once again?
Okay, see, what are the different ways you can delete the data from cluster to SDFS-DFS-RM command? This is command line. Okay. Otherwise, okay, what other option you have? Okay, you have Cloudera Hue, right? So in Hue, okay, so you can open Hue and you have a file browser option there, and okay, you can copy the files there and you can delete files from there. Okay, and okay, Nambari file view. Even if using file view, you can delete the data. Okay, or okay, name node UI. Also, you can copy the data, you can delete the data. Okay, so only with this command, trash works only for this one. Understood? Okay, so this is a problem. Trash works only if you delete any data through command line. Otherwise, it will not work. Okay, so this is one problem. Okay, the next one. Okay, what in case if data center is failed? So now this is the next option. Okay, so now okay, so this is your data. Okay, so what in case if entire cluster is down here? Okay, so this is the big problem actually. Okay, if entire data center is down, Mumbai data center is shut down. Okay, so in that scenario, how data backup? How you can retrieve your data. Okay, so that's the reason normally what they do, they set up a DR cluster. Okay, this is a production cluster, what we say production cluster, and okay, this is a DR cluster. Okay, so now so it is manager's responsibility to decide what data to be moved to DR cluster. Okay, see, normally to store the data you will have one charge in production cluster. Okay, so end of the day, see, whatever data you are storing, for that you need to pay some money, even though inside your company manager will have internal billing. Okay, so if you keep your data in production cluster, that is one cost, and if you want to keep the backup of your data in DR cluster, that's another cost. Okay, so there will be extra cost also for this manager, but however, okay, your data will be safe. So whatever critical data you have, okay, that data will be safe here. Okay, but now the question is that okay, how you copy data from here to here? See, normally inside the same cluster, okay, you have how you copy data from inside the same cluster? Inside same cluster. Okay, within same cluster.
We do HDFS, DFS -.
So normally within same cluster means okay, you will execute a command like okay, SDFS, DFS -cp. Okay, source file and destination file. Source path, okay, source and destination. Okay, this is the command you will use. Okay, normal cp command. Okay, it is a single thread command. What do you mean a single thread command?
No parallelism.
Only one core will be working, okay, to copy the data. Yes, only one core. Understand? Okay, only one client JVM and okay, one core will be working to take care of this work. Okay, but okay, so but I want to copy the data within the same cluster in a distribution way. Understand? I want 10 cores to work on my copy command. In that scenario, you have another command which is called as Hadoop dist-cp. Okay, so this is a multi-thread command. What do you mean a multi-thread command? Okay, so this run MapReduce job. So in this MapReduce job, you can tell how many mappers you want. Okay, so let's say if you tell okay 10 mappers. Okay, so 10 mappers, so each mapper will copy one file from source to destination. Let's say you are copying a directory. Okay, so this is the directory 1. Okay, with 100 files. Okay, so directory 2. Okay, so you want to copy this 100 files to directory 2. Okay, but okay, if you use Hadoop dist-cp command, this is source as directory 1, destination as directory 2. Okay, and if you say okay, I want 10 mappers. Okay, each mapper will copy 10 files parallelly. Understand? Or otherwise, I'll put 50 files. Okay, 10 mappers. So each mapper will copy 50 files parallelly. Okay, understand this? Okay.
But where we are passing these mappers?
Okay, in the command line, in the discp command itself, you can pass number of
Okay.
mappers. Okay. And okay, this is the discp command, guys. This is the first one. Okay. So distcp is a distributed copy command. It launches a MapReduce job to copy huge data across same cluster or different cluster. And this is the advantage. Okay. So across the clusters. Now the next part is across clusters. Okay. That means I want to copy data across the cluster. Means okay, so from one cluster to other cluster. This is what our requirement, right? Okay, it's across the clusters. Okay. In this scenario also, you can use same Hadoop CP command. Okay, but CP command will work only within the same cluster, but okay, this CP command will work within the same cluster or across clusters also. Got it? Across clusters also. This is how it works. Okay. So previously, files previously copied will be skipped. Okay. Suppose okay, when you are copying, okay, so let's say you are copying. Okay, let's say you have directory 1. Okay, of 50 files. Okay, you're copying. Okay, first time you copied to directory 2. Okay, so all 50 files came here. Directory 2, 50 files. Okay, so now inside directory 1. Okay, so there are now more files came. Okay, now we have 60 files. Okay, in directory 2, when you copy directory 1 data into directory 2, so what if the file is already existing here? It will be skipped. Okay, only the 10 new files will be copied here. The CP command. Understood? 50 files which are already existing will be skipped. Okay. So here copied. Because okay, so out of 60 files, 50 files are already there in the destination. You want to copy again those 50 files. Got it? Got it, guys? Okay. So this is like incremental copy, what we say. Incremental copy. So if data is already existing, it will be skipped. Okay. Whatever is new data, it will be copied to destination. The only check for duplicate file is that file name, size, and checksum values are identical. So how it will identify, okay, say this is a duplicate file, or this file is already there in destination. So it will compare the file name, okay, then size of the file, and checksum value of the file. If all these three are matching, then okay, then it will think that okay, it is a duplicate file, or it's a sub-same file. Okay. So here, okay, these are some commands. Okay, Hadoop discp file 1 and file 2. So file 1 will be copied as file 2. Okay, discp directory 1, directory 2. If directory 2 is already existing, directory 1 will be copied inside directory 2. Okay. So if you use -update, so this is what you need to use. Okay. If you use -update, then okay. So if all you are copying 10 files, if any of these 10 files are existing in the destination, those will be skipped, and okay, only the new files will be copied. Okay, if you use update. But okay, there is a command called overwrite. If you use overwrite command, okay, so it will delete all the files in the destination and okay, put all 60 files again in destination, which is waste of time, right? Every day. Okay, so normally they push only the latest files, okay, not all the files. Understood? So whenever you are taking a backup, okay, we use update on. Okay, and okay, this is across clusters. Okay, if you want to use across clusters, Hadoop discp is the first name node, and Hadoop discp and second cluster name node. Okay, so here okay, we say within the same cluster means Hadoop discp cluster 1 and okay, the same cluster 1. Okay, so but okay, this is across clusters means okay, cluster 1 and cluster 2. Cluster 1 name node 1, cluster 2 name node 2. Got it? So this is okay, you can use Hadoop discp command. Okay, but now coming to
here usually in Hadoop we cannot update the existing file, right? If it's already landed in HDFS.
Sorry, sir?
We cannot update the file.
No update, update means delete the file and replace it with new one.
Yeah, that is only possible, but yes, it cannot append any more data.
No.
Sir, there is no continuous replication, no?
Okay, I will tell sir. Okay? Sir, Now you understood, right? Okay, what is the command we use to copy data from one cluster to other cluster? Discp. Okay, discp. Okay. So now, okay, discp is a command. Okay, discp command. Okay. So now I will talk about Hortonworks scenario. Okay, Hortonworks scenario. Okay. In case of Hortonworks, okay, you will have to manually understand, sir? So in case of Hortonworks, how it works? So whatever data they want, okay, your project manager will say, if accounts manager say that, okay, hey, I have found a TB in that, okay, so there are 3 directories which are very critical data for me. Take a backup, okay, create a backup schedule for this 300 TB. Then, okay, Hadoop admin has to write a backup program, okay, and okay, schedule it. Okay, schedule to run. Okay, so launch this job. Okay, okay, so schedule to run continuously. Okay, so you can run. Okay, so you can write the backup code to copy data from one cluster to other cluster, and can run the code with simple data. If it is working fine, then okay, you can schedule it to run continuously on continuous basis. Okay. Schedule to run on continuous basis. What do you mean continuous basis? Okay, so the continuous basis can be hourly basis or okay, every 4 hours or every 6 hours or every day, every week or every month. Okay, it's up to them. However they want backup. Okay, so they will just tell us, okay, I want this data to be copied hourly once or daily once. Based on that, okay, we change this program. Okay, this is Hortonworks. We don't have any automated tools in Hortonworks. Okay, so everything has to be managed. Okay, managed by admins only. And okay, so here to schedule the jobs, okay, we use Oozie. Okay, Oozie is a tool. Oozie tool. Jobs. Understood. Okay, Oozie is a tool to schedule the jobs. Any questions? Okay. So what tool? If somebody asks, okay, what tool you use? Okay, you tell that Oozie is a tool which is used to schedule the Hadoop jobs. Okay. But okay, you have many other tools also. There's not only Oozie. Okay, so many places people are using Control-M. Okay, so there are many scheduling talent. Okay, scheduling tools, right? Okay, so you can tell whatever the scheduling tool you know. Okay, this is about Hortonworks. Everything has to be managed manually. Okay, by admin. Okay, but when it comes to Cloudera, how it works in Cloudera. Okay, so okay, so you're starting. Let it start. Okay. That will become not a problem. Okay, so it is starting, right? Okay, so here there is something called backup, guys. Okay, so replication schedules. Okay, so first what you need to do? Okay, so suppose so here, okay, what you need to do? Okay, so this is a production cluster for you. Okay, but okay, in Cloudera, this is in Cloudera. In Cloudera, what you need to do? So in Cloudera, okay, you need to create a schedule here, guys. Okay, Cloudera is giving an option to schedule. Okay, so it is not a push mechanism; it is a pull mechanism. What do you mean a pull mechanism, guys? Okay, So here you need to create a schedule here. Create a backup schedule here. Create a backup schedule. Okay. So what will happen if you create a backup schedule here? Okay, so these resources will be used to back up the data. But if you create a backup schedule here to push the data from here to here, that also will work. But okay, so production cluster is always busy with some jobs. Okay, in running. Okay, some jobs, user jobs and all. Okay, so if you tell production cluster to copy the data to DR cluster, okay, then okay, it is extra burden on production cluster. That is the reason. What we do, we create a backup schedules in DR cluster itself. Think that okay, I'm in a DR cluster now. Okay, this is my DR cluster. I will rename it my DR cluster. Okay, this is my DR cluster. Okay, so now first, okay, inside DR cluster, what I will do, I will go here and I will click on PS. Okay, so I'll first, okay, I'll do add peer. Okay, so what is the peer name? Okay, so my product cluster. This is the name peer URL. Okay, so here, okay, so I don't have another cluster. That is the reason I'm giving the same cluster. Okay, so here normally what you will give the other cluster Cloudera Manager UI link. Understand? Okay, so this is the Cloudera Manager here. Okay, so this is a Hadoop in Cloudera cluster. You have a Cloudera Manager. This is the URL. Okay, Cloudera Manager is running on 111. Okay, so in this machine also you will have Cloudera Manager. This is running on 121. Okay, so now what you will do? Okay, so here, okay, when you are creating a backup schedule, okay, you need to add a peer. Add peer. Okay, what is peer here? It is nothing but this one. This is the peer. Okay, you need to add this peer. So you need to go this Cloudera Manager URL here. Okay, so this is the Cloudera Manager URL here. And okay, so what username we need to use? Okay, admin, add. Okay. Is it added? What it is saying? Last time also we had the same issue. We resolved it.
So here issues are coming because of same cluster, or in real time it will not come
No,
yet.
sir. No. Okay. What is the issue I'm getting? Last time also I got the same similar issue. Can't create a replication feature alpha. Okay, we'll try and loader 7. I should work actually. So I'm stopping loader 6.
Sir, 7 onwards, it is CDPS.
CDP sir. Yeah. This is okay. The new one which I installed okay day before yesterday. Replication. PS. Let's add peer. Example okay. My underscore prod cluster. Please. To self. So it is saying okay. You cannot create to self. You cannot create a replication peer to self. But earlier okay, they have given us option, but now it looks like disabled.
Again, sir, for this, we need internet connectivity for cluster, yes?
Network connectivity between these two clusters, not internet connection.
Okay, sir. Yeah, got it.
Got it. You got it?
Got it, sir. Yeah, got it.
Not internet, okay? So, earlier they have this option, but how can I create one more cluster here? Okay, I will do one thing. Okay, I will create backup with a different one. I'll put like, okay, add cannot be reachable.
So I think you can install one more this Cloudera
Yes.
software on one host, and then you can give that one, sir.
We need to do that, sir. In that case.
On only one host, sir. Yeah.
But see, the problem here is that okay, the both Clouderas I'm using the same host name and port number.
Correct.
Yeah, I need to change it at least for the next batch.
Sir, so in this replication, complete entire cluster data will be replicated, right?
Okay, so at least because it is saying cannot create a field. So. Okay. So now replication policies actually are replication schedules. Okay. So here okay, create a replication policy here. Okay. So once you add the peer here, guys. Okay. So now it is self peer. It is not taking. So once you added the peer, okay, create a replication policy here. Okay. So SDFS replication policy. Okay. So now it will ask. Okay. Say what is the name you want to give. Okay. So backup. Okay. So accounts project underscore accounts. So this is the name I'm giving. This is the source cluster. Okay. And this is the source path. Okay. So project underscore accounts. Okay. And here okay, you need to select the destination cluster. Okay. If you add the peer, you will get the destination cluster list in this listed here. Got it. Okay. And okay, you can give it to the path there also. Okay. And how frequently, how to schedule. You want to schedule immediately, once or recurring. Okay. If I want to do it okay, continuously, you can go for recurring option. Recurring. Okay. Start time is okay. So let it start okay by 8 o'clock every day or 9 o'clock. Let me schedule 9 o'clock. Okay. 9 a.m. Okay. From today. Okay. And okay, interval every 1 day, 1 hour, 1 minute like this. Okay. So every 30 minutes you want to have every 30 minutes. Run as a username SDFS. Okay, and okay, SDFS. Okay, both are using SDFS users only. Okay, save policy. Now you know what will happen. What will happen, guys?
Yes, the project accounts will be copied.
Exactly. So project accounts okay, will be copied from okay. So source cluster is from this cluster to destination cluster. Okay. So here okay, here okay, you will have my product cluster, and okay, here destination will be my DR cluster. Okay. So that's what the change you will see here. Okay. And okay, every 1 hour you create a schedule like this. In the backend, okay, Cloudera manager only will start the job. You know, as a Hadoop admin, you don't need to write any separate program for this. Understood?
Okay, sir.
Understood or any questions?
So, sir, like it is copying to that project underscore accounts to destination server.
Yeah.
So will it be the this one Cloudera manager server or something else, sir? Some other server?
Which one, sir?
Destination one, sir.
So destination also Cloudera cluster only.
Okay, Cloudera cluster, and again, sir, the replication will be 3 times kind of thing, or it will be 1 time only?
Threaded configuration. Okay, so sir, okay, so this is also a peer, also another Hadoop cluster. Okay, so here, okay, so here my source is okay. My source is what I can say.
Your source is one Hadoop cluster and
Production cluster. Okay, so destination is DR cluster.
Correct, sir. So
Understood.
again, sir, my question is again the data will be replicated 3 times in the destination as well, right, sir?
Of course, yes.
Okay.
When it's a cluster, okay, you will have three copies, right?
Okay, sir. Okay.
Here also 3 copies in the production cluster. You have 2 copies, and destination cluster also you have 2 copies. Okay, and okay. So here, okay, if you want to change also, you can okay see how many you asked me where to set, sir. Okay, so how many map slots I want to use to copy the data. Here you can set up. Okay.
So including metadata and actual data both.
Yes, sir.
Yes.
Okay. So then
Also,
maximum
sir-
bandwidth. Okay, what is the bandwidth you can use? Okay, let's say 1024. 1 GB per second per mapper. Okay, this is the bandwidth they can use. Okay, so 10 mappers use. Okay, it means 10 GB will be copied at a time. Okay, so then 1 GB is too much here. Okay, so you can put it at 100 MB. 100 MB is fine. Okay, and okay, use some 50 mappers. Okay, and okay, replication strategy dynamic. And okay, if you go with advanced, okay, so here you can tell. Okay, so error handling also you can tell. Okay, preserve the block size, preserve replication count, preserve permissions. Okay, so alerts on failure, SNN alert on failure. Okay, so skip this checksum. No, these are important. Abort on error. Okay, so if you want, okay, you can give a log path also. Okay, so here, okay, if you give a log path, okay, what will happen? Okay, so whenever this job is started, okay, so it will write that information into this log. Okay, so tomorrow if there is a failure also, you can see the failure reason from this log. Understood. Okay, so in Cloudera, it is very easy to manage the data copy. Okay.
This is about data copy. What about Hive and HBase copy, sir?
Okay. So even for Hive also it is the same thing. Okay, Hive replication policy. Okay, so again, okay, what is the source? Okay, here, okay, Hive is not there, right? Destination. Okay, so it is not there. That is the reason it is not showing. Okay, so replicate all. Okay, again, okay, here also it is same thing. Do not import Sentry permissions. Okay, or if you want to copy from say Cloudera cluster to Cloudera cluster. Okay, so you can use Sentry permissions.
Sir, we can also go for 6 to 7. Is it not possible? 6 to 7.
You can, sir. It is possible, sir. Why not?
So we can try, right, sir? By
no. The problem here is that 6, 7. Okay, it will work, but okay, both are running on the same IP address. Both Cloudera managers.
Okay. I got it, sir. Got it.
You got it. Yeah. So that's the reason I'm telling. Okay, for the at least next batch, okay, I will separate. Okay,
IP will be
Cloudera
changed.
6 IP addresses and Cloudera 7 IP addresses, so that okay, I can show this replication.
Okay, sir. Thank you, sir. Got it.
Got it.
Yeah. Yes.
Okay. So
here we are setting up the replication, but if you want to just copy on ad hoc basis, also we can do it from here.
So okay, if you want to do ad hoc basis, okay, just say that immediate, only once.
Okay.
Only once. Okay, you tell what time to start.
Okay, sounds good.
Okay, so let's say you want to do one time copy on Saturday. Okay, just put Saturday start time. Okay, you put Saturday, coming Saturday. Okay.
Sir, any idea, can cluster administrator be able to see it, or it has to be a full administrator?
So this is a BDR administrator. You should be.
BDR administrator. Okay.
Yeah. Okay.
Sounds good. Yeah. And can you say just explain that couple of steps on the slide once again, sir? Like the peer, where the peer has to be created first, and
Okay. Okay. So I'll explain here. Okay. So the peer has to be added here actually.
On the destination side.
Destination side actually. Okay. So whatever is your DR cluster, okay, you need to create peers in the DR cluster. Okay. The peer is nothing but your production cluster.
Okay.
Got it. Okay. Suppose okay, now you are copying data from production Cloudera cluster to so DR Cloudera cluster. Okay. So where you will add peer?
On the DR side.
Add peer here.
Yeah, but the peer information will be prod cluster information, isn't it?
Right? So peer is here prod cluster information.
Okay, got it.
So because this is pull request, yes, that is why, sir, this is pull request, yes, that is why it will be.
This is a pull request. Okay,
this is a pull request also can be there in Cloudera.
One second, sir. Okay. So this is pull request. Okay. Now there's another scenario. Okay. So production cluster, you want to update to not DR cluster, you want to update to Azure or AWS cloud. This is also possible. Okay. So now where you add the peer? Understood. Then it is a pull request.
Got it. Because there might be no Cloudera on the Azure, maybe. Is that the reason?
Yes,
Uh,
yes, yes.
Okay. So on the
This is only
top
storage
side,
backup.
sir.
It's only storage backup.
Yeah, got it. So on the top one, once we add the peer on the DR side, and we have to go to the prod Cloudera, and the peer will be shown over there. We just need to select the peer.
No. Okay, see, the peer will be shown only in DR, sir. Okay, see, there is no, okay, this production cluster doesn't know that, okay, there is something happening here. They added a peer here.
Yeah. So can you say what happens next after we add the peer?
Suppose, okay, first you add a peer. Okay, so that, okay, so DR cluster will be knowing that, okay, production cluster information. Okay.
Yeah.
So now create a
Just
schedule.
it's a link, sir. It is.
It's not a link, sir. Actually, it's an information about, okay.
Yeah, we provide the production cluster information into the DR cluster.
Okay.
Yeah,
Now
that is
create a schedule. The schedule
automatic
schedule. Okay, give source. Okay, source is in the schedule. Okay, so now you say source is okay. Here. Okay. So destination is DR Cloudera cluster.
Yeah, DR.
Okay. Now recurrence. You tell, okay, daily once. Okay. Hourly.
Oh, so we literally not touching the prod cluster at all.
We are not touching prod cluster at all. Okay, we are not using prod cluster resources also.
Got it. Thank you, sir.
You got my point now?
But sir, in case of Azure and AWS, we will be using push request. Yes, sir.
Push request, sir. Yes.
Okay, sir. Got it.
In this scenario, okay, some resources from production cluster will be used to do this activity.
So you'll be pushing from production cluster to Azure.
Yes.
Azure or AWS.
Yes, sir. Okay. Are any questions? Okay. Okay, guys. Okay, so I hope you got it. So in Cloudera, so you know it is not a manual job. So it is like automated one. Only setting up the schedule is a manual work. Okay. Once you set up the schedule, okay, then automatically, so data copying will happen based on the schedule. And okay, you can set up how many mappers you want. Okay, what is the bandwidth you want? Okay, and okay, which log you want, in which log you want to write it. Okay, so everything you can set up. Okay, so whenever this schedule start writing the pulling the data, it will write the log into that place. Okay, so tomorrow if there is any failure in the schedule or failure in this schedule run, okay, so you can go and check in the log why it is failed. Got it. So you are not doing anything in production cluster. You are doing everything in DR cluster only here. This scenario. Clear? Are any questions? Okay.
Just one more question. We are there is an option to preserve the permissions, right?
Yes, sir.
So when we are doing this activity, do we need to make sure we are doing it from an admin account?
That's what it is telling. Please provide, okay, what it is saying, okay, replication policies. Okay, so here, okay, you need to provide a user, okay, which has good, okay, permissions actually. So run as a username. Okay, so here if you type, okay, admin, the user admin must be a super user because preserve permissions is enabled.
Awesome, got it.
Okay.
Yep.
Got it.
In case the production cluster data loss, can we run the show with the DR cluster?
Of course, you can run the show, and okay, if you want to, you can push it back here also, right? You can tell, okay, now you can tell this cluster to push data back to production cluster also. It is not only pull, it can push also. Got it?
Okay, again, we need to data back to production cluster.
Yes, yes. Any questions, guys?
Sir, DR and production cluster should be the same Cloudera only, not in Hortonworks and Cloudera.
It can be Hortonworks also, but okay, here okay, but okay, what is happening here? Okay, it is expecting a Cloudera URL only.
Just give the URL and then it will proceed.
Yeah, you got my point.
So any disaster recovery happened, so there will be a delay, right, sir? Some like downtime.
Sometime, right, but not so much, right?
We need to recover the data to DR to production. There will be a gap.
Yeah. Sometime, okay, it will take some time.
Okay, sir.
Okay.
Sir, Hortonworks లో బ్యాండ్ విత్ హ్యాకప్ తీసుకునేటప్పుడు హ్యాండ్ విత్ ఏమన్నా ఇంక్రీజ్
Yes, okay, you have to set the bandwidth also.
in command line only, right? In Hortonworks.
Everything in command line only, Hortonworks. You need to write a Hadoop DCP command. If you don't know how to write it, okay, just Hadoop DCP and type it. Okay, it will give you complete help.
Okay.
Not on CMD.
ఒక ఎగ్జాంపుల్ ఒక 100 GB కి ఎన్ని మ్యాపర్స్ పెట్టొచ్చు అనేది ఏమన్నా ఉందా సార్?
Sir, okay, so here, okay, can you see Hadoop DCP? Okay, so here, okay, these are the different options. Okay, bandwidth, okay, per map in MB. Okay, so how many mappers you want? Okay, so -m, number of mappers. Okay, so you can choose -overwrite option. Okay, you can choose -update option. Okay, so see, very simple, sir. Okay, what Cloudera is doing, okay, everything they have given in the command line, in the UI. Yes, sir. No?
So can we leave mapper the number of mapper as blank, so it will take default something whatever is required?
Default, sir. Default one mapper. Okay. So end of the day, what Cloudera is doing, okay, Cloudera is taking everything from the UI, and it is in the back end. Okay, it is preparing. Suppose, okay, here we are saying that, okay, skip checksum checks. Okay, the same. Okay, you have something here. Okay, skip okay, some checks. Okay, checksum. We'll checksum. I guess this is the one. Okay. Yes, check. This is the one. Okay. Check some checks. Okay. Between those. Okay. So then, okay. So about on mirror. Sorry, error. So okay. So target snapshot. Okay. This one. Okay. So about on snapshot different values. Okay. RDiff is the command. Okay. So number of mappers. Okay. Here, okay, it is saying maximum map slots. Okay. So here, okay, you will -m. Okay. Maximum bandwidth. Here, okay, you give -bandwidth. Okay, so the same thing actually. Okay, so here, okay, whatever you are saying, okay, delete to trash, keep deleted cells, okay, delete permanently. So if you want to delete permanently, you can use -delete. Okay, so same thing. Okay, so here, okay, they are showing in the UI, taking all the options from us, and in the background, okay, it is creating a DCP command only and executing it. Very simple. But the entire work will be done by Cloudera manager. Okay.
That should run in shell script or do Woozy and control them anywhere, right? We can do this.
That is for Hortonworks.
Yeah, Hortonworks.
Okay. Yes. For Cloudera, yes, okay, you have replication scripts. Okay.
Sir, backup you told yes just now, just before this backup we covered for Ambari DB and all. So in that backup we need here also in Cloudera also, or no need because
SQL backups, huh?
Yes, sir, SQL backups.
Yes, sir. Okay, it is required, sir. Okay, Cloudera will not take any MySQL backups. Okay.
Okay. So, sir, one question is like, let us suppose if Ambari DB went down for some reason, and we lost the metadata. So in that case, how to once the backup is available, that backup we need to put in some place so that
Yes,
it
sir.
will
You need
be-
to restore, sir. You need to MySQL restore commands. You need to check.
Okay, okay, sir. Okay, got it.
Got it.
Got it, sir.
Yeah. Okay then. Okay. So number it here. Again, starting Hortonworks. Okay, maybe for the next match, I will show everything in CDP only, guys. I will not go to, because okay, I got the new version of, okay, earlier, whatever the version I had, okay, it was having some bugs on Vue. That is the reason, okay, I was not showing, okay, in Cloudera Manager 7. Okay, so, but now I got the latest version of Cloudera Manager. Okay, so, and stable version, okay, I got. Okay, so I guess I will be showing, okay, everything in the CDP from next time onwards, in the next batch. So, okay, Hortonworks is starting. Let it start. Okay, so this is the failure scenarios, data center failure. Okay, so there may be temporary site loss or permanent site loss. Okay, if it is a temporary site loss, okay, so you can, okay, but however, okay, for whether it is temporary site loss or permanent site loss, okay, you need to have backup. Okay, if you want to have a backup, you need to copy data from data center A, production cluster to data center B, DR cluster. Okay, so to do this one, okay, you have DCP commands. So I will show you, okay, how it will be in Hortonworks, how it will be in Cloudera. Okay. So the next thing is that snapshots, which is bit important, guys, which is bit important for all of us. Okay. What is a snapshot, guys? What is a snapshot?
Backup only, sir. Kind of, it will revert back if we want to the last snapshot. Yes, if backup went wrong or something.
Okay.
In that case,
Here, you know, what is the problem here, guys? What is the problem? Okay, here. So all these backup schedules, okay, so all these things are fine. Okay, but somewhere, okay, we have something red. What in case, okay, somebody deleted data, it went to trash. Okay, but okay, he didn't observe that, okay, till 6 hours. How to retrieve this data? You got my point? How to retrieve this data? Okay, so let's do one thing, guys. Okay, so let's do one thing. Okay, so now, okay. I have a file, okay, here student.txt, guys. Okay, that. Okay. What is this guy, guys? What is this one? Can somebody tell me what is this number? Okay.
So process ID.
Okay. Otherwise, okay. What are these numbers, guys?
I have process IDs.
Process ID. What process? This is a file, sir, not process. Okay. So before, okay, I start with snapshots. Okay, so I need to explain, okay, what is this hard link concept actually? Okay. Okay. So okay, normally when you store any file into hard disk, what will happen? Hard disk will have the file allocation table, right? You remember our first class? Huh? First class. Okay, so
Yes,
every
sir,
hard
yes.
disk will have a
File allocation table
file
and
allocation table. Inside that, okay, you will have file metadata. Okay, but
Right.
okay, inside the, for the table, okay, first, okay, you have a serial number. What is the serial number called? You remember this one?
MBR, sir, master boot record, sir.
No. In the first class. Okay, so there will be some reserved space. Okay, that reserved space is called as a file allocation table. Okay, so now if you see, okay, there is something called serial number. Okay, so now if you see, so when there is a file here, okay, 1, 2, what are these 1, 2, 3? What is this entire line called? One inode. So in this table now I have 3 files. It means okay. For as per hard disk, it says I have 3 inodes. Okay, so it means okay. Every file will have a inode number. Okay, so whatever number you are seeing here, this is a inode number. Okay, so for sample 1, this is the inode number. For sample 2, this is the inode number. Okay. Now I will say create sample 3. Okay, so cp sample 1.txt to sample 3.txt. Okay, so now if I say sample 3.txt, okay, what is the inode number for sample 3? Okay, it means okay, every file is having separate inode number or not? Huh?
It's a separate.
So what is the content on this file? Yes, this is the content. Okay, this is the actual data, correct? So try to understand here. Guys. Okay, so let's say this is my data. Okay. Hello, how are you? This is my data. Actual data, or not? This is my actual data. Hello, how are you? Okay. I store my actual data into a disk without any file name. Do you have any person in the world without a name?
No, sir.
Okay, so in the same way, you cannot create any file or you cannot store any data into any storage without a file. Okay, so this is my data. To store this data, I need to have one file name. Yes or no? So I cannot directly store this data without any file name. So for that, okay, what I'm doing? So I'm telling that okay, so this is a sample 1.txt. Okay, so for this actual data, I'm giving a name. Okay, sample 1.txt. Okay, so this is your human body. Okay, no human body will be there. Okay, without okay a name. The same way, no actual data will be there without a name, file name. Okay, so here okay, here this sample 1.txt. Okay, so now what sample 1.txt is representing? If I say print sample 1.txt, what it will print?
Actual data.
It will print hello, how are you? Okay. So now the question is that okay, can one actual data have 2 names? Huh?
No file names.
Huh?
No.
Yes, sir.
One actual data, 2 names.
Yes, sir. We can.
How?
So we can copy
can possibly
the same
the
data
same
with
names.
another name. Same data can be
Okay.
copied.
No. Okay. So let us take this scenario. So this is a human body. So to identify this human body, so what we need? Okay, we need a name. Okay, let's say this human body, I'm giving a name which is called as Kiran. Okay. So this is the human body. This is the actual content. Okay. But okay, to identify this human body, we are giving a name which is called as Kiran. Okay, correct. Can this human body have one more name also? Some nicknames,
Yeah.
right? Okay, so some
Alias
people
name,
call him
alias
as
name.
yeah,
Alias.
so Bujji. Okay, so it means okay, the same body here, okay, but with the same body with a different name. Okay, yes or no? Yes or no? Okay, so it means okay, one human body has two names here. One is Kiran, official name. Maybe okay, this is a nickname. Maybe okay, so maybe okay, so his spouse may call him or her like with a different name. Okay,
We can have many names.
Many names. Okay, it means like one human body can have many names, but one official name. Correct or not? Okay.
Yes.
So now, okay, now, if you know this name, you will call this human body with this name. If you know this name, you will call this human body with this name. Okay. If somebody knows like a different name for this one, okay, so they'll call you using this name. But okay, you call with any name, but end of the day, the same guy. Got it? Okay. So maybe Chinni. Okay. So this is the new name. Okay. So for this guy. Okay. But again, look at the same human body. Okay. So you put whatever number of names, but okay. So is this okay? Let's say this human body is 70 kgs. Okay. So is it changing? Since we have three names, okay, is human body becoming 210 kgs?
No, sir.
Huh? No, right? Okay. So this is human example, human. Okay. So the same example we'll put it here. Okay. So here, okay, this is your actual data. Okay. To store this actual data, so you need to give a name. This is the name. This is the official name. So nickname 1. Okay. Nickname 2. Okay. So this is the main file name. Okay. So now for the same actual data, we give one more name. Maybe, okay. You got it? Huh? Can I give a name like this? Let's see. Okay. So okay, there is a name sample3.txt. Okay. I will give one more name to this sample link. Okay. Sample3.txt, sample4.txt. Okay. Link sample4.txt. I just created a link here. Okay. But now, okay. Okay. See, for both, okay. What is the ID for both? So actual data is with this number. Okay. So now both the files, this is sample3.txt, this is sample4.txt. Okay. So both are pointed to the same file or not? Same idea or not? Huh? Yes or no, guys? Both are pointing to the same thing? Okay. Now if I cat a sample3.txt, sample4.txt, both are printing the same data. Okay. So it means okay, I have given. So if you look at this output, you feel that okay, both files are different. These two are two different files. Yes, but these two are two different files pointing to the same actual data.
Yes.
Okay. Because of this one, now, okay. So because I created this like this, okay. How much space? Okay, will it take okay 306 plus 306 or only 306?
306.
Huh?
2 times it will take.
One time it will take.
One time.
306
One time, sir.
bytes. Okay. Since I put two names, it will become okay 612 bytes. The same thing I explained here, sir. Okay, so you have a human body of 70 kgs. So I'm giving okay I'm putting 3 names. If I put 3 names, this human body will become into 3, 210 kgs. Okay, it's the same human body. Because of giving multiple names to the same human body size is not increasing. Okay, in the same way, you have a data. Okay, you have a data, and you are giving multiple names to this data. So it is only one copy. So here both are referring, all the names are referring same human body. So all the file names are referring the same actual data. Understood? So here, okay, now, okay, you may look at, okay, this one, okay, this is the main file name, this is the nickname of this file. Okay, but both are pointed to the same actual data. Okay. Now, okay, if you see the storage size, okay, you will see as 2 files, but okay, actually it is taking only 306 bytes because it is only one same file where 2 names are pointed here. One main file name, one is the nickname. Both are pointed here. Okay. So now, if I want to delete a file, okay, like this case, okay. So what do you mean of deletion of a file? What do you mean of deletion of a file?
RM file name.
What do you mean deletion of a file?
Remove the file.
Remove the file. Deletion of the file means deletion of this entire data. Yes or no? Deletion of this actual data. So if I delete a file, it should become, okay, it should create 306 bytes free space. So in that scenario, what I need to delete? Sorry, you have 1 GB file, sir. Okay, 1 GB data on your hard disk. Okay, to free up the space, okay, you will delete the file. If you delete the file, it will delete the actual data. Yes or no? Deletion of a file means okay, deletion of actual data. Means deletion of actual data. Okay. So now, okay, when actual data will be deleted, okay, actual data will be deleted permanently. Okay, when all the main names, okay, main file name and okay, nicknames are deleted. Okay, even one main file name or nickname is existing. Okay, actual data will not be deleted. Okay, so this is the rule, guys. Okay. Deletion of a file means deletion of actual data. Okay, deletion of actual data. Okay, but actual data will, when okay, this actual data will be deleted. Okay, if both the names are deleted. Okay, but okay, you delete this one. Okay, okay, until this is there. Okay, this will be there. Understand? So if you want to delete this data, you need to delete all the main names and nicknames. Then only your data will be deleted. Got it? See, data is deleted. Okay, to confirm, okay, actual data is deleted means there should not be any main names or nicknames to the file. Then only. So now if I delete sample.txt, okay, so let's say rm sample3.txt. Okay, so I deleted a file, right? Okay, will it free up the space? Okay, so I will do one thing. Okay, df fun du fun ch. What is the okay? Okay. What is the total utilization here, guys?
du-sh.
Okay. 128 KB, na?
Yes, sir.
How many bytes? Total 128K. Okay. Okay, 128K. Okay, so now I'm creating a soft link for this one. Okay. Sample. Okay. ln. sorry, I'm creating a link sample4.txt to sample5.txt. Okay. So it means okay, now one extra file has come here, right? Extra file means 306 bytes. Okay. Now you run do-sh. Is it showing the same space after creating this file, or okay, it is showing the different space? Huh? Tell me, guys. See, application one more file of size 306, but it is showing still 128 KB only. Okay. Now, okay, I delete this file, rm sample5.txt. Okay. Is there any change in the size? But okay, if I delete this file also, sample4 also, rm sample4.txt. Now you see there will be some change in the space. You got my point, guys? No? Okay. So we'll do one thing. I'm creating a sample3.txt. Okay. This is the file, sir. Vi sample3.txt. Okay. So now there is sample3.txt. Okay. What is the size of sample3.txt? 306 bytes. Okay. So now how much is used, okay, in this path? In the current path, what is the total utilization? What is the size of this all the files here? So here I have 128 KB. Okay. So here, okay, so here I have, what are the files I have? Otherwise I can remove rm, even rf. How many files we have here, guys? I have 3 files. Okay, do-sh. Okay. What the size I have here? All 3 together, okay, I have 60. Okay, so let's say, okay, sample1.txt. So this is, okay, so there is a data 1, not 6 bytes data, actual data. Okay, 200 bytes actual data. Okay, there is, okay, so this is the actual data. There are the actual data. This actual data name is sample1.txt. This actual data name is sample2.txt. Okay, this actual data name is sample3.txt. Now, guys, this is what, okay, we have. Okay. All together, how many bytes we have total? 306 plus 200 plus 306. 812. 812 bytes. But why it is saying 64K, 60K? Because of all these things, right? Because of all these things, it is showing. Okay, so okay. Now, okay, this is the 60K it is showing. Okay, it is showing 60K. 60K. Okay. Now, the sample.txt, okay, sample.txt, I'm creating a link. This is sample3.txt, which is pointed to this one. Okay. Okay, now I'm creating another file, sample4.txt also. So now, okay, ln sample3.txt, sample4.txt. Okay, now I created a link. Okay, how many files I have? So there is extra 306 bytes. Okay, increased, right? Okay. So before it is 60 KB. Okay. Before sample4. Okay. After sample4.txt. 60. Now what is the size? Is there any change in the size? There's no change in the size. What does it mean? Okay. Is it taking extra space? Sample4.txt. It is not taking. Okay. So you create one more file. You create sample5.txt. Okay. ln sample4 to sample5.txt. So now you can see that there are 5 files. But okay, even if you see do you have message, okay, it is going. Okay. Sample5.txt, which is pointed to the same. Okay, understand? So before sample4.txt, after sample4.txt, after sample5.txt, size is same because all files are same. This is the main name and these are the nicknames pointed to the same data. Okay. Now I want to delete this 306 bytes. Okay, when it will be deleted? If I delete sample file, will this 306 byte deleted?
No, sir.
So RM
Sample
sample
3 deleted, which you config.
sample 5. Okay. So now is there any change in the size? No. Okay. No change in the size. Okay. Delete sample 4. Okay. RM sample 4. Sample 4.txt. Okay. So is there any change in the size? No. Okay. Now RM sample 3. Now is there any change in the size?
Yes, sir.
It means okay, if this is there, okay, this is also deleted. It means okay, if you want to delete any data, so there should not be any links to that data, any names attached to that data. Then only actual data will be deleted. You got this concept now? Huh?
Yes, sir.
Okay. So the same concept they used, okay, in Hadoop also. It's the same concept they used in Hadoop also. Okay. So, but they are calling it like a snapshot. Okay. Okay, snapshot means okay, it is creating a different link for the same file. Okay, so let's see how it works. Okay. Okay. So now guys, okay, so try to understand. Okay, I'm creating a directory here, guys. I'm creating a directory. Okay, project RF project 2 directory. Okay, this is the directory I created. Okay, so now what I will do, I'm creating 2 files. There are no files. Okay, I'm creating 2 files, guys. Okay, there are 3 files. Okay, so 3 files. I'm creating sample1.txt, sample2, sample3. Okay, these are the 3 files of what I created. Sample1, sample2, sample3. Okay, sample star. Okay, so sample1 is hello, how are you? Second file is I am fine. The one is hope you are doing good. Okay, these are the 3 files. Now I'm putting sample1.txt under the newly created directory. Okay. So now, okay, let us see whether it is copied or not. There sample1.txt. Okay, so it means okay, there is 20 bytes data. Okay, what is this one? Okay, so this is okay. This is the data, actual data. This is the actual data. 20 bytes. Okay. You gave a name for this data. Is what is the name you have given? This is the name you have given. You are calling it like with this name. Yes or no? Okay. Now, if you print this one, okay, what it will print? If I say cat. It's printing actual data. Correct or not, guys? Will you agree with me? Okay.
Yes,
So now I'm saying that again. HDF has list snapshotable directories. Okay, so this command will help me to list out all the snapshot enabled directories. All the snapshot enabled directories. Okay. So do you have any snapshot enabled directories here? There are no snapshot enabled directories. Okay. So now what I will do, okay. So using, okay, login to okay. I'll take one session with the HTTP user also. Okay. HTTP user. So here what I'm doing, okay. With this command, I'm enabling snapshot for this directory. What is the directory I'm enabling snapshot? By default, the snapshot is not enabled for any directory on HDFS. So after creation of the directory, you need to tell, okay, hello snapshot, press enter. When you say hello snapshot, okay. I cannot execute this command, okay, using ln because ln doesn't have sudo permissions, okay. So that is the reason I'm using HTTP user here, okay. So if you want to disable snapshot, okay, you can use this command, disable snapshot, okay. Okay. So again, come back to session 2. Okay. So this is session 2, ln session, okay. And okay, so HDFS icon create snapshot, okay. Now you run this command list snapshotable directories. Now you see list snapshot. Earlier, okay, it didn't show anything, but now it is showing, okay. So project RF underscore project 2, okay, okay, is enabled with snapshot. Okay. Now, if any directory is enabled with snapshot, I can create a, okay, so I can create snapshots. Okay. So now what I'm doing, okay, so this is what I'm creating now. I'm creating the snapshot. The snapshot I'm creating, what is the snapshot name? Snapshot 01. Okay. I'm creating a snapshot. When you create a snapshot, okay, what it does, okay. So this is the directory, okay, this is the directory. Under this directory, what are the files we have? Under this directory. So now take this one. Okay, so this is the directory here. Okay. Under this one, I have sample1.txt. 1.txt. Okay, under this directory, I have sample1.txt. Okay, so when you create a snapshot, what it is doing, okay, what this command is doing, okay, so it is saying that snapshot is created. Okay, so on a particular directory, when you create a snapshot, whatever files or directories we have inside this directory, okay, when it is taking a snapshot, it will create a nickname for this file. What is the nickname it will create? It will create a nickname. So what file you have, okay, under this one, sample1.txt. Okay, so this is sample1. To this actual data, okay, it will create a nickname like this. Is this one? This is the new link it created. Okay. This is the new link. So in this link, you have something called dot snapshot. Now you see. So now if you go and see this one, ls-l project 2, you will not see the dot snapshot directory. Are you seeing this one? Dot snapshot is a hidden directory. Okay. But if you type a dot snapshot, it will show. Okay. If you want to see what is there inside this dot snapshot, whatever the snapshots you have taken, okay, that's each snapshot is like one directory. So S01. Okay. So if you see inside this one, you will have these files. It means, okay, whatever the files we have inside this one, it will create one link like this. Actually, it is a duplicate name for this sample1.txt. Okay. So now, because of creation of this duplicate name, is 20 bytes becoming 40 bytes? No, right? No, right? Okay. So now you created, okay, like this, how many snapshots I can create? Can I create one more snapshot also? So I'll create one more snapshot. Okay. Okay. Before, okay, I guess, okay, I will do one thing. Okay. I will copy one more file, sample2.txt. Okay. And I'm copying one more file into this directory. Sample2.txt. Now you can see there are two files. Okay, so sample2.txt. This is the sample2.txt under this sample2. Okay, what is sample2.txt? Okay, actually, let and all. Okay, so here sample2.txt. Okay, add sample2.txt. Okay. This is the actual data. For this actual data, the name of the file is this one. Now I will create one more snapshot. I'll create one more snapshot. Okay. When I create one more snapshot, what it will do? Now, how many files I have inside this one? Inside this, I have two files. For each file, it will create, okay, one nickname. Okay. So here, this is the file. Okay. This is one more nickname to the same file. Okay. What is the nickname? S02. Okay. But for this one, this time it has created S02. This is the nickname here. Okay, first file has two nicknames. Second file has only one nickname. Because okay, when okay first snapshot was getting created, okay, sample2.txt was not there. But now when second snapshot is getting created, sample2.txt is there. Okay. So like this, okay, like this, every file okay, will be okay. Whenever you create a snapshot, a new nickname will be created for each and every file inside this directory. Understood or any questions? Okay. So now, as a user, can I delete this? So when I will say this entire data will be deleted. When I will say I'm fine will be deleted, both the names are deleted or not? Huh? So now, what I'm doing here, okay, as a user, if you want to delete, okay, so dfs -ls. Inside this one, okay. So you cannot delete the hidden content actually. Okay, you can delete only the content what is visible here. So dot snapshot is a hidden content, so you cannot delete dot snapshots. Okay, so even if I delete okay sdfs -rm -script trash. Okay, sample1.txt. Sample1.txt deleted. Deleted, right? It's not even move to trash. Okay. But it means okay, so sample1.txt is deleted means okay, this link is deleted. But what are these two links? They're still there, right? They're still there. This data also still there. Okay. So now when I add this one, okay, so can I delete this one also? What did I say? Snapshot is read only, so you cannot delete this file. Okay. Can I delete S02 sample1.txt? It's also read only. You cannot delete this file. Okay. So you cannot delete these files. Users. Only users can delete this file. So it means, okay. So by mistake, if user delete this file also, the same file data is in the form of, okay, is with a different nickname. Understood? Or any questions? Even if you delete the main file, this is the main file, right? The main file here.
How we can get this data into main directory now?
Sorry?
How we can get this data, deleted data into main directory?
Okay, so now, okay, now you can do one thing. Okay. You have this file, right? But can I cat this one? You can read this file. Okay. Now I can copy this file, right? dfs -cp, okay, cp 2. Now you see. Now you go and see dfs -ls. I deleted the file. Now the file got restored. It means, okay, now you are creating a, so now what you are doing is you are creating the one more nickname like this. Actually, the main name is deleted. Okay, so this will be like a nickname now again. So these, okay, if main name is deleted, okay, these nicknames are the main names. So now you are creating one more nickname with this name. So it is pointed to the same data. So when this actual data will be deleted, if all the three nicknames are deleted, then only actual data will be deleted. Got it? So I hope, okay, you got the concept. Okay, what is this snapshot concept? But okay, we will continue tomorrow on this part. Okay. Thank you, guys. Thank you.
Hello, sir. Hello.